Hey everyone, in this video, I'm going to show you how to calculate molecular weight, otherwise known as molar mass. So without any further ado, let's get started. So you already know how to count atoms in a chemical formula. And here what we're going to do is take the mass from the periodic table, which as a reminder is this bottom number for any particular element. And the reason that this number is a decimal has to do with isotopes, which means that for any given sample, say of nitrogen, most nitrogen atoms are going to have 7 neutrons because 14 minus 7 is 7, but a very small fraction of them will have 15 neutrons or even 16. And this number at the bottom is a weighted average. So if you have a pile of nitrogen atoms in front of you, a very small fraction of them are going to be heavier. Most of them will have the mass of 14, and then the average has the decimal point there. So when you're calculating the molar mass and you're dealing with actual samples of real stuff, you have to take into account the average mass, which has these decimals here. Okay, so with that in mind, let's calculate. So we have sodium chloride. And in order to find the molar mass, otherwise known as the molecular weight or molecular mass, we will simply take the mass for each of these elements and add it together. Okay, so there's one sodium, that's 22.990. And there's one chlorine. The mass of chlorine on the periodic table is 35.45. And then we're going to add that together. You may use your calculator, because I don't like to add that stuff in my head either. So we have 22.990 plus 35.45 equals 58.44. And the units for this are going to be in grams per mole. So there are 58.44 grams per 1 mole. Now, for magnesium hydroxide, you already know how to find the number of atoms that are there. That will come into play when we're finding the molar mass. So we have one magnesium, 23.305 from the periodic table. But we have 2 oxygens and 2 hydrogens, and you have to take that into account. So we're going to do 2 times oxygen. Oxygen is 15.999 plus 2 times hydrogen, which is 1.008. Okay, and then you have to take into account order of operations here. So we have 2 times 15.999 equals, that's 31.998, plus 2 times 1.008. Okay, it's going to be 34.014 plus 23.05. And actually that should be 24.305, my bad. Plus 24.305 equals 58.319. Okay, again here, this is ammonium nitrate. So it's an ionic bond between 2 polyatomic ions, ammonium and nitrate. Notice that each of them has a nitrogen. Even though they're part of different polyatomic ions, you could combine those together. So you could say there's 2 nitrogens, one here and one here, 14.007 plus 4 times 1.008 plus 3 times 15.999. Okay, and again, that's just a matter of putting that in the calculator, adding it together, easy peasy. So 3 times 15.999 plus 4 times 1.008 plus 2 times 14.07. That's going to be 80.043. And so you might be asking yourself, well, why do we have to do this? Well, we're going to be getting into more complicated problems where you can predict how much of a product you're going to get in a chemical reaction and stuff like that. And to do that, we need to know the molecular weight, otherwise known as molar mass, of any given compound.